Now that we talked a little bit about symmetry, let's talk about a very specific kind of symmetry, an axis of symmetry. When we looked at this picture of a circle previously, we talked about drawing lines down the middle of it that would allow us to fold over one side onto the other. This line that we're folding over is an axis of symmetry. That means that it's a line that we can fold one object over onto itself and it'll match up perfectly. That is that this edge here will line up perfectly with this edge over here once we fold it from one side to the other. This also shows up when we're talking about quadratic functions. For example, here we have the function f of x equals x squared. That's been graphed and we have our table or t-chart. If you look at the actual graph, you can see that there is an axis of symmetry running right down the center through this central point or vertex, which is located here. You'll also notice if you look at the individual points that are marked, this point here, which is one space away from our axis of symmetry, has a corresponding point in the other direction from the axis of symmetry, also 1 point away. If you go up to our next defined points here and here, you'll notice that the point that is to the right of the axis of symmetry, or the positive side, is 2 spaces away, and the point that's to the left, or the negative side of our axis of symmetry, is also 2 spaces away. You'll notice that this continuously happens, that a point on one side of the axis of symmetry will match up exactly with a point on the other side of the axis of symmetry. You can also see the symmetry of a function like this by looking over here at the table. If you look at the table, you'll notice that there's a pattern in our values of y, in this case 4, 1, 0, 1, 4. There is almost an axis of symmetry as you cut those y values in half. That it goes 4, 1, 0, 1, 4 shows that symmetry, which also appears in our graph. So whenever we're thinking about an axis of symmetry for a graph, you're merely looking for whatever line that graph can be folded over on. Take, for example, this new function. Instead of it being f of x equals x squared, we now have f of x equals x squared plus 4x plus 3, which is what's graphed. As you look, you can notice that it seems to be centered around a single line. In this case, that line occurs at x equals -2. Once again, when we look for points on either side, we could, for example, see that there are points, for example, here at 0, 3, and another point at -4, 3. What we talked about a moment ago was that there should be a point on equidistant from the axis of symmetry. In this case, our point 0, 3 is 2 spaces from our axis of symmetry, and our point -4, 3 is also 2 spaces. So they once again match up. We could continue looking for points like this. For example, if we look a little bit farther up, we'll notice that we have points that are essentially at about 1/8 and -5/8. When we look at these, we should be able to see that from our axis of symmetry, it's moved over 3 spaces to the right or positive side, and there's a corresponding point 3 spaces to the left or negative side. So once again, these axes of symmetry that run right down the center of all of our graphs are something we'll use to define and find values for quadratic functions. And a little later on, we'll learn how to find them.